I'll meet you at the bottom. There's still one more thing I must do before I go.
It's incredible! It's gonna be some kind of a record! Everyone loves a slinky. You gotta get a slinky, slinky.
Slinky, slinky, everyone loves a slinky. Hey guys, today we're going to investigate spring behaviour. More specifically, we're going to look at the behaviour of a helical spring up to and beyond its elastic limit. That's one of these bad boys. We're also going to look at the behaviour of a combination of these springs, both in series and in parallel. So we're going to need a 30 centimeter ruler, 3 expendable steel springs, like that, a short length of stiff copper wire, a mass hanger and assorted masses, and our torch stand, clamp and boss. This is a relatively easy experiment, guys, but as always we've got to be a bit safe, so we're going to wear our safety goggles just to prevent any damage to our eyes that may occur as we're stretching the springs beyond and up to their elastic limit. Okay, so to get started, really simple. We're going to put one of our springs on the end of our clamp, like that, okay? And using your pencil on your eye, you're going to measure the length of the original spring, okay? And you're going to make a note of that, record that in meters. So for example, the length of this spring will be 0.32 meters for me. It might be different for you guys, okay? Then really simple, what you're going to do is you're going to add your mass hanger to the spring. Allow that to rest. And now you're going to measure the extension of the spring, so how the length of the spring has changed. For example, my spring is now extended further 3 centimeters, or 0.3 meters. So to the mass hanger you're going to add 100 grams. Same thing again, you're going to measure the extension on the spring and make a note of that. Correlate that to the load applied. It's really straightforward, guys. We're just going to keep adding the weights, recording the extension, keep maintaining that until we'll end up with a spring like this. Now this is being stretched beyond its elastic limit, which means it won't return to its original position. For each value of the load that you add, guys, you're going to calculate a total extension of the spring and record this extension. And that's done by subtracting the original length from the extended length and you measure. You're then going to plot a graph of force in newtons against extension in meters. The elastic limit of the spring will lie beyond the linear part of your graph, so using your results you can actually estimate this value. To the limit of proportionality, the spring will obeys Hooke's law.
Catching James! How? Go get him, Catching!
Yes. F equals kx. K is known as the stiffness or the spring constant of the spring. Now you can actually calculate this constant by taking the gradient of your graph. So now that we've found a stiffness constant for a single helical spring, we're going to up the ante a little bit and try some combinations. So you're going to join 2 springs in parallel, like so, and you're going to repeat the experiment again. Just as we did before, we're going to record the original length of the combination. We're going to add the mass hanger, record any extension that's observed, and we're going to add masses and record any extension up until the elastic limit, which we determined for a single helical spring previously. So when we've done that, we're going to plot a force extension graph just as we did before, and we're going to calculate a stiffness constant for a combination of 2 springs in parallel. So now that we have a spring constant for a single helical spring and a combination of 2 springs in parallel, the final step of the experiment is to investigate spring behaviour in series. So what we're going to do, we're going to take our stiff copper wire and bend it into an M shape and attach 2 springs, like I'm doing here. And exactly the same experiment again, attach them to the clamp, record the original length of the springs. We're going to add our mass hanger, record any extension that's observed, and as we did before, continue to add weights, recording the extension each time until the elastic limit has been reached. This time we can add weights up to twice the elastic limit as we have previously determined. Again, when the elastic limit has been reached, you can plot the force extension graph for this series combination and calculate the spring constant. Well, that's the end of the experiment, guys. Now this is a really good test and development of your basic measurement and experimental techniques and skills. These things will all help you in the future. Now, having a look at your results, you should be able to determine that the spring constant for the series combination is half that of the single spring, as there's double the amount of the extension for the same load. Whereas when you look at the parallel combination, the spring constant is double that of a single spring, as there's half the extension for the same load. Well, I've been Simon. That was Investigating Spring Behaviour, and I'll see you again soon.